Okay, so homework problem, or I shouldn't say solver problem one, let's put it that way. Over here are the initial conditions for the well. Make sure that yours match these before you start, or you're going to end up getting different answers than I am. Also, it's important that after you work each solver solution, you go back and you restore the original. So in the first problem, um, we want to figure out how close can we get to the worst case scenario and still have a well that's a go. So let's go back and recap some basic concepts. I told you in the homework problem that this company used the present value, and I don't know why they have PW here, but it should be present value for a 20, which means that they're assuming that they get a 20% annual rate of return on the investment. And you get a go, no go decision based on whether that number is positive or not. So you can see right now that number with our base case well is $1.9 million dollars, and that would indicate it has a positive present value with a 20% rate of return annually demanded of it. Therefore, this project would be a go. And then the question becomes, how bad can these things get for the scenario to still be a go? And so there are three parameters that they're concerned about. They're concerned about at how high rate will the well come in, and then what happens to commodity prices in the future. So we go to our friend Solver in this corner, and remember that's on the data tab. We click Solver, and first of all, we have to have an objective that has a formula in it. And so what we want to do is we want to go over here to Z34, which is the present value 20, and select that. And we want it set to a value of 0. So this will tell us exactly where the line is between a go well with a positive present value or a no-go well with a negative present value. And we have three variables that we're going to model in this solver solution. So I click this. We're going to affect the initial oil rate. I insert a comma. The oil price increase, insert another comma, and the gas price increase, a final comma. But we've got some constraints. Our first constraint is that the initial oil rate has to be, we're going to assume that it has to be greater than or equal to 400. In other words, the worst this well will come in is at 400 barrels a day. Next is we're going to assume, worst case, that the oil price may decline or increase may be equal to or greater than minus 20. That may get you twist your tail a little bit, but remember it's minus 20, so it has to be greater than minus 20. In other words, minus 20 is as bad as it can be. And same thing for the gas price increase, greater than or equal to minus 20. Okay, we've got all those factors in there, and now we get a chance to see what we have. 400 minus 20 minus 20 all makes sense. Let's solve. It tells me that they've got a feasible solution, and I want to keep the solver solution. Incidentally, I didn't click on it, or I didn't point this out to you before, but in Solver, we want to use the method GRG nonlinear. That's the one that seems to be the most applicable for us. I already told it to save my solution, so I come over here and I see, wow, the well can come in almost as low as my worst case scenario and still be a go, but look what it did. Not only did it not decrease my oil prices, it actually had to increase my oil price and my gas price to make it work. What Solver seems to do is take the parameter that matters the most and make the biggest determination or biggest change in that. In this case, like we found out, changing the oil rate, initial oil rate, which is going to affect how much oil you eventually recover, is the most important parameter. But I'm not very happy that it told me this oil rate and raised the prices. So I know that even with neutral prices, if the well comes in the worst case scenario, it's right at make or break. So based on this, that leads to problem 2. So I'd now like you to pause the video and go to problem 2 and work it. On to problem number 2. Very importantly with Solver, the first step is to go back and put back in my initial baseline parameters. So 500 barrels per day, 0% increase in oil and in gas. So now I'm like, all right, rascally rabbits, we need to put some more conditions on you. So I gone into Solver and I've already made the changes. This doesn't change because my decision point is still the present value 20 number and I want it set to 0. The variables I'm varying don't change, but I put in some additional constraints. I've put in, okay, the initial oil rate can't be greater than 500 because I don't want it to give me some sort of a model that's coming in higher than I want it to be. And I put in the additional constraint of that the oil price decrease has to be less than -10, and same for the gas. So I'm basically saying it has to be between -10 and -20 for the oil changes, or oil and gas price changes. Click solve, says I've got a feasible solution, and I click OK, and I see what I've got. I scroll down, and it says here, okay, oil can come in at 431.5 barrels per day, provided I see only a -10% decrease in gas and in oil. And if I wanted to stress test it even more, I could go in and I could load in a -15, change the constraint to -15. But you can see this is what it's saying. Let's assume that commodity prices decrease 10% a year. Then if my well comes in at less than 430 barrels a day, then I'm going to have an uneconomic well. On to problem 3. As I begin problem 3, remember step 1 is to go back and reset Solver to the baseline conditions, so 500, 0, and 0. Now what we're saying is, with shale wells, so much of the oil is pumped initially, and the money's basically made or lost in terms of the major order magnitudes in the first 2 years. We feel pretty good about commodity prices, so we're not worried about them. But what we are more worried about is the fact that the well does make oil at the rate that we think it's going to make oil. And we've also started to see some significant variations in the well cost. We know that a huge percentage of the well costs are driven by the frac prices, and also they're driven by some very long laterals. Therefore, if we were to have a problem drilling the well, if we had something that broke off in the pipe, we're worried that there could be as much as up to $1.5 million variance on the more expensive side on the well cost. Okay, well, let's model that. So if I come back into Solver, again, my key point is to set my company's decision point, which we've defined as the 20% present value number, to 0. And then we change the variables. Well, we still are worried about the initial production rate, but we're not worried about the other two. Instead, we're worried about the decline rate, insert a comma, and the investment, or the well cost. In this case, I want to change this to say that it comes in at least 450 barrels, because I think that's as low as the worst case would go. So we make that change. And these we just delete because I'm not and now I want to add, pull it back over, and now we're worried about the decline rate. We think it will be at least 40%, so it's got to be, but under 50%, so it's got to be less than or equal to 50, but greater than or equal to 40. I can click the OK button, but it just takes me out to the base thing, so this allows me to stay on the page. And now I think the drilling cost, the gross investment in the well to be more precise, is going to be greater than or equal to 7.5 million. But think I did that one backwards. So it's going to be greater than or equal to 7.5 million. And here I need, so greater than or equal to that is correct. I'm going to change this one. I'm going to turn it around to 9 million. So less than 50 but greater than 40, less than 9 million but greater than 7.5 million. And let's hit solve. It says it found a solution. Now we come over and see what we got. So now it says, all right, if I come in close to the worst possible initial oil rate and my decline rate increases to 43.5 and my well cost goes up to basically 8 million, then I've got a break-even well. And so this starts to tell me that, boy, a combination of an increased well investment of $500,000 plus a decline rate that's close to the midpoint of what I think my worst case band is, and an oil rate that's about as bad as I think it's going to get, I'm going to have an uneconomic well. Again, you can narrow these parameters down. The virtue of Solver is that it allows you to look at multiple things. You could stop using Solver and just do lots of run lots of scenarios if you wanted. In fact, I would probably end up doing that after the Solver gave me an initial look at what the sensitivities are and allowed me to get into the ballpark of the final answer. I hope that you're comfortable with doing this. You can anticipate on our last exam that there will be a Solver problem. And I want to point out to you that you need to understand what cell I'm fixing. In this case, I used the present value of using 20% money. If you notice over in the chart, it's got the discount rate of 9%, which is what it shows here on the present value of 9% on the well. And the reason it's 9% is that's how a lot of banks require you to run the number. They want to see the number run for a 9% present value rate. But a lot of companies use 20%, but not all. They could say 15, they could say 25. So I want you to know why I set that variable to be the one that's 0. And the reason is because that's what the company decided the decision point should be. You can probably anticipate that on the exam, I'll be giving you a different decision point for the company. Be sure to get with me if you have any questions, but I think if you watch this video, if you have questions a few times, it's going to clear everything up. Good luck.